Hi everyone, I'm Brian. I'm a DevRel engineer here at Aptos. I'm very happy to be speaking with Alex from Econia and Sasha, a researcher here at Aptos Labs. I'll let them introduce themselves and then we'll start to dive into some of the new research that has come out of Aptos Labs, mainly Zaptos. So to begin, I want to allow Alex to go ahead and introduce himself.
Hey everybody, I'm Alex, co-founder, CEO of Econia Labs. I've been building on Aptos since April 2022, and I am so happy to be reunited with Sasha here in the Aptos Labs office in Palo Alto. Just visiting for the week, co-working out of the office. It's glad to be back with old colleagues and some new friends. Econia Labs, the company I helped launch, has launched two products on Aptos mainnet, Econia fully on-chain order book, and more recently we've been working on the emojicoin.fund project, which has just been such a blast. And I'm excited to talk about a high-performance Aptos infrastructure today because it lets us build what I like to call the reverse mullet. You know, it's all party in front, but it really is business in back because the blockchain that we're building on has some serious distributive systems technology. And today I'm excited to get into the weeds of that.
Hey, I'm Sasha. I'm leading the research here. I'm with Aptos for more than 2 years, building the infrastructure, building the best infrastructure in Web3. And I'm very happy joining the conversation today, talk a little bit about the new stuff that we're building, in particular Zaptos, Raptor, BlockSTM V2, and maybe have some time, maybe some more cool stuff that's coming soon. So let's do it.
Yeah, awesome. So very happy to dive in. Like when I think of blockchains, I really think of two main components, right? There's the consensus layer, kind of how do you come to agreement between transactions in a block, and then also there's the execution layer, like how do you update blockchain state? So I know recently there's been a lot of announcements from Aptos Labs around this new pipelined architecture called Zaptos. Sasha, so pretty much what is Zaptos? How does it improve some of the performance benchmarks for Aptos?
So Zaptos is the overall architecture of the blockchain. Like it's the end-to-end from the point the transaction get into the system to the point the transaction get out of the system. It's the entire architecture of the blockchains, all the stages. And I'm going to go deep into it in a second. But consensus, our new consensus is we're going to call Raptor, is one component of this big architecture, this like pipeline stage architecture. So we have the Zaptos, we have the Raptor is the consensus as BlockSTM. Currently we're running BlockSTM for execution, and we're working on BlockSTM V2 for the next generation of our parallel execution. And if you think about it, today in my mind, Zaptos, the overall architecture, together with the consensus component Raptor, together with the BlockSTM V2 execution, that's going to be the end game of the blockchain infrastructure for the foreseeing future, at least for the next 5 years. Because as I would try to explain to you, the latency is going to be optimal and the throughput is going to be way beyond the demand.
Okay, so really we have at the consensus layer, we really have something called Raptor, and then at the execution layer we have something called like BlockSTM V2. And everything together, this entire end-to-end process, this end-to-end architecture, we're calling ultimately Zaptos. Is that how I understand things?
Yeah, that's correct. So let's start with the Zaptos. Let's understand what it is. So let me give you some historical overview. So back in the Diem days, we introduced this pipeline architecture, which if you think of a transaction coming into the system, there is a few stages it needs to go through. First, there is a transaction dissemination where we disseminate, like clients talk to the full nodes talk to validators, then validators need to disseminate the transaction to all other validators, including the leader of the consensus. Then it goes to the consensus stage where we agree on the next block, the order of transaction. From consensus, we take the blocks, we move them forward to the execution in the pipeline. The execution component is going to execute the block. From there, it goes to storage. We are going to store the block. Then we're going to certify the block with another round of communication to make sure safety, everything is all correct. And then we are going to send it back to the full node and send it back to the client. So this is the all-to-all of a blockchain system. And historically, even in the Diem days, we made it pipeline. The reason it's a pipeline architecture is because we want to be able to utilize all the resources in the system. If you think about it, execution, for example, is a very compute intense, whereas consensus is very bandwidth intense. So while doing it, while pipelining it, we can execute block number 7, for example, and in the meantime, we can agree via consensus on block number 8. So we were able to utilize all the resources all the time. We have 100% utilization on CPU because we are executing block number 7, and in the meantime we're utilizing the bandwidth because we're already agreeing on the consensus on the next block. So this increased throughput by a lot, and that was the Diem days, and then now the new thing that we are introducing, which we call Zaptos, is we also want to shrink everything and reduce the end-to-end latency because, it's pipelining, it's pipelined. The throughput is very high, but we still need to go through all these stages. Like transactions come in, we disseminate the transactions, then we agree on them in consensus, we give them some order, then we execute, then we commit to storage, and then we communicate back to the client through the full nodes, right? But with Zaptos, we realized that some of the stuff we can do optimistically in parallel, basically shadowing some of the latency of some of the stages. Now, our consensus is optimal. We can talk about it in a second. It's 3 hops consensus. But after 1 hop, everybody already gets the block. So at this point, instead of waiting another 2 hops to the block to be confirmed, we already start pre-executing the block optimistically, assuming it's going to be confirmed in the future. So we execute it, we committed to storage, and we actually certified already the execution result, and everything is done by the time consensus is ready. So all this latency that used to be like an added latency to the consensus, now it's shadowed with the consensus, and by the time consensus is done, basically we are done. Blockchain, we are done. End-to-end latency becomes the consensus latency, and the cool thing about it is that now, because our consensus has optimal latency, we show that we can process 20K transactions per second with a sub-second latency for each transaction. This is insane. If you compare it to what is available now, some other blockchain can do sub-second transaction latency, but they can do it for only low throughput, like a few hundred transactions per second. We can do it for 20K transactions per second with this new architecture, because the dominating component for latency becomes execution when your throughput is so high. But because we are able to shadow all this execution time with the consensus, basically we are able to keep very low latency even under very high throughput.
Yeah, that's very awesome. I think like involving pipelining into Zaptos is like very crucial feature. I think like maybe a very simple way to help like explain this to the audience that potentially doesn't have like such a deeper technical background. Like how would you really explain pipelining? Like the way to bring like a different analogy. And feel free to correct me if I'm wrong. It's like let's say there's the 3 of us, and we're all tasked to wash dishes at a kitchen, right? And so you have one person who takes the dirty dishes, moves it to the sink, and then from the sink someone is washing the dishes, and then we have a third person who's like drying. We all can be working not in parallel but in a pipeline fashion. Like, is that an accurate way of describing like what Zaptos is?
Yeah, that's a great example. That's how that's pipelining, right? And as you said, you increase the throughput because you have a new ready dish every stage, right? Every time you dry a dish, you have a new ready dish, right? You don't need to go through the whole process of like I take a dish, I wash it, I dry it. No, you increase the throughput. But this is what happened before pipeline. Now, I was trying while you were speaking to thinking how to make a Zaptos of it. I don't know, maybe you can help. But think about something like you are washing the dishes, and by the time you finished washing the dishes, they're already dry. You see the magic here? We're basically shadowing the latency of drying the dishes under the process of like washing them.
I see. Okay.
This is what we do with execution. By the time we finish consensus, we already executed everything. We already committed everything to storage.
If I could offer some thoughts on this too. I think that central to this entire design is this notion of optimistic execution, and it is originally what drew me to Aptos. The idea is that when something is going through the pipeline, you can sort of assume that it's going to end up the way that you want. This is the optimistic execution model. And because of that, you can do the later stages of it all at the same time. And assuming the first one completes successfully, that means that the second one would have completed successfully if you had waited to start it until later. But because of this optimistic assumption, they're all done at the same time, which is sort of what Sasha was talking about. And in my experience, this drew me to Aptos because the sort of optimistic execution I was thinking about when I first started designing here was different transactions. Because previously in the past, when you think about this linear execution model, It sort of began with Ethereum, was the original, like on-chain code, smart contract chain. But the problem is that in Ethereum, you have to, it's stop the world is the term that people use in order to execute one transaction. So one transaction has to execute, then another one has to execute, and then another one. And the result of that is that even though there might be two transactions that don't touch the same state or don't modify the same area of the memory in the computer that is the Ethereum blockchain, they still have to wait for one another to complete. Whereas on Aptos, you can start doing both of those at the same time. And you can say, okay, if transaction 1 were to complete, this would be the result. And if transaction 2 were to complete, this would be the result. And you can run those on 2 different cores in the same machine. And then when they're both done, you realize, oh, they didn't conflict. They said they would touch different areas of memory. So you commit them both at the same time. And that model, at just the execution layer, has now been extrapolated to the entire pipeline architecture that is Zaptos, which is really exciting because it means that any of the smart contract code, the move code that I write is not just executing in parallel at the execution layer, but it's also getting disseminated throughout the system in this optimistic form. So it's really the extension of a core principle that drew me here, which is what I'm so excited about, because the design of Aptos is really centered around this whole idea of extracting maximum throughput from parallelism. And that comes from a very rich distributed systems history and a principle-based approach to making the system as performant as possible. If I could, rewind maybe 2.5, 3 years to when I first started building on Aptos, it originally came from this intuition that, when I learned about it, Sasha spoke about it. He talked about the Diem/Libra days. What does this mean? Well, Facebook essentially developed this entire web scale blockchain architecture with, from what I understand, was like $500 million of research and development. And that doesn't include all the overhead that you have with a startup. That Facebook already sort of was taking that on. That was really just research for the most part. And so when I learned about it, the message that I got from this was, okay, if anyone can build a scalable distributed system, it's Facebook engineers with endless resources. And I'd say that intuition has proven largely correct. At the time, the optimistic concurrency really appealed to me because I had been more interested in building on Solana because at the time that was sort of the high throughput chain. However, the application I was interested in building, a fully on-chain order book, was constrained by the parallel execution environment of Solana. Rather than being optimistic, it used a pessimistic form of concurrency that doesn't allow transactions to speculatively, get ready ahead of time. You'd have to sort of prevent 2 transactions from going in parallel in certain cases. And that made it so that an order book could not be implemented the way that I thought it should be implemented, with atomic matching and permissionless market making. And when I learned about Aptos, I learned that they had this optimistic execution model, and therefore I decided to go to the hackathon. That led to another thing, ended up launching a product. And part of the real promise, I'd say, of this entire chain is first of all, there's the abstraction. And so in this original analogy of having the person who brings the dishes, the person who washes the dishes, the person who dries the dishes, you have this division of labor that overall makes the workflow more efficient. And it also makes it so that each person only has to sort of stay in their lane. Even though I'm, of course, fascinated with the entire overall architecture, I really just have to think about what is sort of in my immediate, circle of concern, which is, in this analogy, I'm just bringing the dirty dishes over to the sink or whatever. I'm only having to really focus on writing some of this on-chain code. And I can delegate out to the rest of this entire technical stack, the consensus, the committing to storage, and I can just let that part happen. And then when I look back at what I'm trying to do, everything is already in the runtime. Everything is already in source. And so I don't have to think about those things. And the really exciting part about it is that if I can go back to this original point, that this was designed with years of foresight by an immense research team that has carried over largely into Aptos Labs. And so they thought about a lot of these things beforehand, and it has resulted in this very elegant and vertically integrated tech stack. So everything from the storage up through the move, runtime, up through the consensus mechanism is all designed to work in lockstep with every other element of the system. And in some sense, a lot of the fundamental blockchain problems here have already been solved. And now it's just the sort of hardcore engineering efforts of getting it, just 5% faster, just 5%, more throughput again and again and again. And if you have this data-driven, empirical, results-driven approach like Aptos Labs does, it ultimately means that you have this foundation of all of the components playing together in the right way. And then you just keep getting better every day with little improvements here and there, and that compounds exponentially. It doesn't have this sort of, I don't know, like Franken-chain approach that you could maybe see in other places where, for example, the EVM, has a lot of people building on it. So people thought, okay, let's take the EVM and let's maybe strap it onto this new consensus design that we think is good. Or maybe we have, some new runtime, but we want to stick to some of the principles of Ethereum in terms of their storage or whatever. And then people are kind of stuck because they're frozen around these old models. But what Aptos Labs has done is said from the beginning, okay, let's just forget the fact that other people might have, bags in whatever asset, or they might have used this language. Let's build it from the ground up to be as performant and as efficient as possible. And they really just have the singular goal of let's build the best distributed system possible. Let's build the fastest computer that we can, the computer in the sky. And as a builder, I just view it as that. I view it as a computer. And the idea that it is really just designed to be as performant as possible is all I need, because then I know that the transactions are going to be inexpensive. There's going to be low end-to-end latency. And when they finally, have this product that the user can actually touch and use, what they see is just an experience like they would in Web 2. They click a button and it says done, and the money's in their wallet. And they gain all of these improvements that come with blockchain systems. You'd have the permissionlessness, you have more liquidity because there's more people all around the world. And you also have this flywheel of innovation because you don't have to wait for someone to give a stamp of approval. You don't have to overthrow something coming. You can just build something new. You can get it out in the world tomorrow. And you know that if you're building it on Aptos, that it's going to be as performant as possible.
I think that's probably one of the key advantages of Aptos was able to see the shortcomings of like the EVM and the SVM and then build, what Alex has called out, like a better developer experience when building Aptos. Specifically, when you mentioned Solana and their static parallelism, you have to declare upfront, which accounts you want to touch, right? And so that kind of, alongside having Rust being like a lower level language where it's very error prone, I think, I think the Aptos Labs team was able to see that and then also create the Move programming language with, optimistic parallelism. Also, another thing that I want Sasha to mention maybe is probably the new performance benchmarks with Zaptos compared to prior architecture systems. So like what are the new like latency times, and also what is the new throughput, and also and then we can start with Alex, like how does this affect the creation of like new applications?
We need to talk about latency under low throughput and latency under high throughput, and this is very, very different. Latency under low throughput, we're able with Zaptos to improve it by 200 milliseconds, which maybe not sounds like a lot, but in percentage it's like huge amount because our latency was already sub-second before. So the P50, the average transaction, is going to take about half a second now to commit. And I'm talking about all-to-all finality confirmation, not like some block time and not some optimistic confirmation. Like from the time we get the transaction from the client to the time we respond to the client and it's confirmed and irrevocable, half a second, we under low load. Now, under high load, it's becoming higher. And the reason is because, as I said before, if you have high load, you need to execute all this load, right? Execution takes time. Committing to storage takes time. Everything takes time. It's not only the consensus that dominates the end-to-end latency anymore under high load. But because we are able to shadow all this latency, right, with the Zaptos approach, as long as the throughput is below 20K transaction per second, we are able to maintain this sub-second end-to-end latency with around 800 milliseconds rate latency for each transaction, for 20K transaction per second. Now, if we go higher than that, then we cannot shadow anymore, and that's becoming to be additive. But everything below 20K we can do with sub-second transaction per second. If you compare it to other blockchains, for example, Solana, they have 2 seconds confirmation end-to-end under a load of like a few hundreds transaction per second, and even this is an optimistic confirmation, right? If you compare to Sui, they have a sub-second latency, I would say around 700 milliseconds, but also they never show it on high throughput. They only show it like very low throughput, like a few hundred transactions per second. Once throughput will go high, their latency will go much higher, because this is also because their consensus cannot handle high throughput with low latency. With Zaptos, again, I'm going to repeat this crazy number, we can do 20K transaction per second with about 800 milliseconds end-to-end latency to confirmation.
What's most important to the end user is the end-to-end latency, and there's almost like a critical threshold that you need to reach, which is around like several hundred milliseconds, because at that point your brain, you can't even tell. It's like you've blinked. And so once you get, is it 80 milliseconds? Is it 70 milliseconds? For the end user who's clicking a button and wants to see transaction confirmed, that doesn't really matter. But we're not there yet. And we're finally within like an order of magnitude where it's starting to approach that. And the result is that right now, for example, if someone trades on emojicoin.fun and they click, swap, they can see a confirmation and it's practically instantaneous. Or someone sends stablecoins to a friend, or they send money off a centralized exchange, or whatever sort of like common use cases that are happening in crypto nowadays. The result of this, the most tangible thing, is that you don't really notice that you had to wait. One consumer product that did a really good job of honing in on this like principle in their early days was Spotify. There's like a really good dramatic series that people can watch about the origins of this and how the leader of the engineering team and the founder were so laser focused on this idea of when you click play, the music has to start within like a certain number of milliseconds. And they're like, I don't care how you do it. Get to this number of milliseconds and the user won't care how you did it. And they got it. And now when someone clicks play on their phone, as long as they have an internet connection, it's as if it was already there on their phone, ready to play. Like you don't notice. And so because as humans, we have, like a limited sensory ability to compute that something has happened. As the decade and a half of blockchain evolution has been going on, things have been getting faster and faster slowly, but it's been like, oh, it was 14 seconds, or it was 3 minutes. Now it's 1 minute. Now it's 30 seconds. Now it's 15 seconds. That's still an eternity for computer science. And that's still an eternity for anyone who's thinking about, okay, how long am I watching this thing spin around on my phone before it says it's good? So I think that we're finally reaching this threshold where like the infrastructure is good enough to not notice. And it's getting even better where now if it's good enough to not notice, then you have this whole new class of consumer apps that people are going to want to onboard and use because they couldn't have done it in Web 2. Like there's things that you can't do, like emoji coins you couldn't do in Web 2 because what firm is going to like put their brand behind that? Are they concerned about losing the people that were already using their fintech services or whatever? But you can innovate, you can deploy new things, you can try new experiments, and the more experiments you can do and the less you notice that it's happening, the more demand there is. And I think that's where the true bottlenecks happen, is the moment that some big consumer app or maybe even a Web 2 company decides, okay, we're going to integrate with a blockchain. You need to make sure that throughput can scale. And the exciting thing about Aptos is that it under low load gets you to this point where you don't notice, and under high load, it can still keep up.
Yeah, I think it's a bit under-discussed that Aptos, amongst all the layer ones, has some of the best performance benchmarks. Like I don't know of any other layer one that's claiming can actually reproduce 20K TPS at sub-second latency. What do you want to see built in this space? Where do you think the evolution of decentralized finance will go? Things like that.
Yeah, as far as what comes next, we're already working on this internally. I had a great whiteboarding session with David Walensky, head of engineering, yesterday. I think long term, our technical roadmaps involves getting more involved with the transaction lifecycle, and even something around consensus. If there can be some way to do payment for order flow that leverages this idea that there's like 20 transactions going through. Some people are clearly going to be paying more to get theirs ahead of the line. How do you incorporate that in the full end-to-end user product? These are the kinds of questions we're excited about. In terms of like people building on Aptos, though, I don't think you necessarily need to have some grand vision of what HFT looks like in 10 years when it's built on blockchains or whatever. You just have to have an idea and the interest in trying something new and to ship a prototype, because the Move programming language is designed to be simple. There's plenty of tutorials, there's developer resources. The indexing is designed to, there's a new indexing SDK that makes it more easy to get the data you want, so you can, display the things you use. Really, I would say to anyone who's like interested in building, just start hacking on something. Go to, the next hackathon, like reach out to me and we can talk about how you can integrate with emoji coins or with existing Econia infra. I think the core thing is to just start, because at that point there's a real rabbit hole you can go down. And I think that what Aptos does very well is it positions itself to create a new, very sticky class of developers who kind of understand what the vision is about. Because a lot of the people I've met in this ecosystem who started building on Aptos, once they were here, they realized like there's something special and different about this. And it's fun to be, in those early days with the people who are helping to build it out in their image, make suggestions to the core team. And so, yeah, if I could give any message to aspiring builders, it would be like, just build something, write even 10 lines of Move code and just go from there.
Coming into from different ecosystems, I was actually a bit surprised by how easy it is to write a smart contract in Move. And, particularly with Zaptos, I think I think the biggest impact we'll see in the applications and amongst builders is clearly around decentralized finance. And I'm glad that I have Alex here, specifically around market makers as well. I think the faster we get and the higher throughput we get, we'd allow more market makers to ultimately quote tighter spreads on their books, right? And I think hopefully we get to a space where more of these professional market makers from TradFi come and make markets here on DeFi, right? And eventually, obviously, bridge those lines between Web 2 and Web 3. And I think some other innovations that can happen in the space are clearly like there's maybe an idea with like social. I mean, social. Maybe you don't need to depend on latency that much, but they do require high throughput. A lot of people are posting. Maybe there's user generated content, things that are being shared out. And then another space is obviously gaming, where you can have like in-game economies. People are always trading, new tokens or new skins, and there's like ideas around composable NFTs. So really cool that the new Zaptos architecture is able to support some of these high throughput, low latency needs.
Can I talk a little bit about some of those ideas you mentioned? Like there's so many different verticals. And you talked about like first trading. Obviously, I think that is to me like the killer use case for high throughput blockchains. I'd say that like the store of value and sort of like payments or stablecoin transfers things are sort of solved already. Like they can still get a little better, but I think the trading still has a lot of room to run, and it's the on-chain versus like off-chain volume ratio just grows every day. More people are moving on chain. And when you talk about these other applications, whether it's gaming or social, I don't know what that necessarily looks like when it's put on a blockchain. It changes the nature of things because blockchains sort of like naturally just financialize things. But the result of this is that, like you said, if people are in game and they want to trade something, the key thing is that they're trading. Like there needs to be a framework that allows them to place trades. There needs to be some kind of framework that lets people launch a market, get liquidity on that market, have it be as efficient as quickly as possible. And that is exactly what we want to build, is the liquidity and the trading layer for Aptos DeFi and just for crypto DeFi more broadly. And one of the use cases that I'm excited about when you talk about bringing more financial activity on chain is this idea of real world assets has been pretty popular lately. I'm not so sure about how much demand there might be for like one tokenized apartment in New York trading on a blockchain or something like that with real estate. But I do think that stable coins are a really big market for RWAs because we already have so much volume trading in forex markets around the world. It's disjointed. It is by definition non-jurisdictional because it is trading one government's like fiat currency against another government's fiat currency, and it trades 24/7. And so crypto and on-chain trading platforms are the sort of logical next step for this. And I think that unlike things like equities or bonds, which have all of this red tape, I don't necessarily expect to see stock exchanges moving on chain in the next 6 months. But with more countries wanting to expand their balance sheet and issue more debt and sell it on the blockchain in the form of stable coins, there's more of an opportunity to just move these forex markets on chain. And it greases the wheels of global mercantilism by removing this sort of necessary scaffolding of intermediary banks that hold a little bit of your collateral in one asset or the other. You can just do an on-chain swap and pay your counterparty in stables for whatever country they're in. And so I think that is one of the really exciting use cases that I'm looking forward to, because it is this blend of traditional financial activity. It's like an on-chain exodus where the better product is actually on-chain. It's unifying markets in a globally decentralized marketplace. And it doesn't have to deal with some of the hangups that we've seen with people trying to bring things on chain, because there's already people in the US who are talking about things like a stablecoin bill. Like I'm in town because partially tomorrow I'm going to a stablecoin conference in SF, and people are trying to make these things happen. And governments know that they can, expand their balance sheet and sell more T-bills if they just let the stables flow. So I'm excited for that particular use case. That's like sort of a pet idea for me. But I think that it and all the other trading we're seeing is really just the continuation of a system that's proving itself day after day. It's better, it's more efficient, and it's getting battle hardened as time goes on.
Right. Yeah, actually, I was also a bit curious. I know, Alex, you deal with a lot of the, trading infrastructure and you work with a lot of market makers. Do you ever still get market makers that come in and say like, hey, we need our latency requirements to be like this amount? And do they end up, how do they end up reacting to something like, Zaptos, right? Now being close to 200 milliseconds. Like, do they still say like, we can't make markets there, or they need to quote wider, or how do you Like, how do you work with those market makers?
Yeah, so the function of a market maker's behavior on chain incorporates a lot of different behaviors, including latency, including the reliability of the oracle, how much liquidity might be on a centralized exchange, because they might want to hedge if they're just using a reference price on Binance or whatever. And it all just comes down to the spread either gets tighter or looser. Like they can make markets on a 13-second time horizon or whatever. But market makers have been doing it with Uniswap v3 on ETH mainnet, but it just results in it's a less capital efficient system. And so what this means is that the end user has just a little more skimmed off of the top from them in their trades. Everyone gets slightly worse price until you start just slowly clipping away the latency. You start slowly increasing the throughput, which is where Aptos is now with this next generation pipelining framework in Zaptos. Is it provides a groundwork where you can just say like, okay, we've got it this fast. Now let's look at the flow. Let's do a flame graph on all the code. What is taking 99% throughput? How can we get that down? And then you fix the next thing, and then you fix the next thing. You get everything just a little more efficient. And in concert, it becomes this extremely efficient vehicle for moving financial information around. So yeah, in terms of market makers, there's not necessarily like we can't do it at this latency or whatever. It's more so the end user is going to get a better price the faster it is.
Yeah, I'm always very curious about the trading layer. I think we're coming close on time, but I want to end on final words of wisdom you'd give given the new performance features with Zaptos.
Yeah, so I just want to recap what we're building on Aptos for the next generation of the infrastructure. So we're talking here a lot about Zaptos, which is the architecture, the end-to-end throughput and latency. Now, this pipeline architecture, that it has a lot of stages and a lot of components, and the two main ones that are the bottlenecks for many blockchains and consensus and execution. And we are innovating there. We're building Raptor for consensus and BlockSTM v2 for execution. And each one of them will have very low latency, very high throughput. BlockSTM v2 is going to scale to much more threads. If BlockSTM v1 scales to 16, 32 threads, BlockSTM v2 is gonna scale to 64 and even more. And I know, Alex, you're a big fan. And once you see the details of the new algorithm, it will completely blow your mind. I guarantee to you, it's just insane. Years of watching BlockSTM working in production, seeing all this workload that makes trouble. You realize what are the real bottlenecks. BlockSTM v1 is great, but with the new insights that we're collecting over the 3 years and seeing it. We basically mostly Vati Gelashvili, he basically came up with all these ideas. It makes the system really, really, really efficient, and I'm looking forward to share the details with you. Maybe next podcast, maybe other forums. But I mean, I'm really excited about everything that goes there. It's really, really, really cutting edge.
Yeah, my words of wisdom would be to any builders out there who are want to get into crypto or who are already in crypto and are maybe looking what to do next. I would try and instill this principle of building what you set out to build in its fullest expression without smoke and mirrors along the way. I think that you can always sort of try and chase some kind of hyper-delusionary incentives. You can chase whatever the current narrative that might be over in 3 to 6 months. But if you stick to a foundational vision and you ask yourself, what does this look like if done right when it's taken all the way out to the logical conclusion? Try and think about that and then build toward it. And I'd say that if you are building anything that's even remotely related to trading, that's going to result in building on the system with the best performance possible, and that's going to result in building on Aptos.
Very excited for the new research coming out of Aptos Labs, and I'm glad we had Alex on this talk and Sasha as well. So thank you, everyone.
And thanks for having me. Always glad to be back at Aptos Labs, Palo Alto.
Always happy.